Hello, this is Mr. Brooks, and welcome to Lesson 6.2, Properties of Parallelograms. In this lesson, we're going to use relationships among sides and among angles of parallelograms, and we're going to use relationships involving diagonals of a parallelogram, or transversals. Would also be considered the diagonals of the parallelograms. Our first theorem in Chapter 6 tells us that opposite sides of a parallelogram are congruent, and then they give us a flow proof to try to decide if that is correct. Let's see if that is true. Alright, how do they do it? First, we're given its parallelogram. So we know both pair of opposite sides are parallel. So we know the top is parallel to the bottom and the left side is parallel to the right side. Well, if the top is parallel to the bottom, then you know that angles 2 and 3 are congruent. And if the left side is parallel to the right side, then angles 1 and 4 are congruent. Alright? So, and since AC is congruent to itself by a reflexive property, the two triangles are congruent by angle side angle. And if the triangles are congruent by angle side angle, then we know all pair of corresponding parts are congruent. So AB is going to be congruent to CD, and AD is going to be congruent to BC. So if it's a parallelogram, both pair of opposite sides also have to be congruent. Now the very bottom paragraph on page 312 is a very important paragraph because it basically explains that if you have parallel lines, you already know that your same side interior angles are supplementary. So if you have a parallelogram, your consecutive angles are going to be supplementary. And they use this just like a theorem in the book, even though it does not state it as such. So you need to know, when the book says consecutive angles of a parallelogram are supplementary, that's the exact same thing as saying if parallel lines, then same side interior angles are supplementary. If you look at this figure, if the top and the bottom of the parallelogram are parallel, then you can tell angles 1 and 2 are going to be supplementary, because if parallel lines, then same side interior angles are supplementary. That's like angles A and B in our parallelogram up above. And the same thing if we have the left side is parallel to the right side, well, then you know angles 3 and angle 4 are going to be supplementary as well. Why? If parallel lines and same side interior angles are supplementary. That's like angles B and C in our parallelogram. So hopefully you can understand that your consecutive angles of a parallelogram are supplementary. In example 1, since we know consecutive angles of a parallelogram are supplementary, and hopefully you remember supplementary are two angles that add up to 180, they ask us to find the measure of angle S. Please pause the video while you try to figure out the measure of angle S. Hopefully you will agree, measure of angle S would simply be 180 minus 112. So the measure of angle S is simply 68 degrees. Quick check number 1 asks us, if the consecutive angles of a quadrilateral are supplementary, must the quadrilateral be a parallelogram? Please pause the video while you try to figure this out. Well, since we said if parallel lines and your same side interior angles are supplementary, we know the converse of that also to be true. If your same side interior angles are supplementary, then parallel lines. Well, then the converse of this will also be true. If consecutive angles of a parallelogram are supplementary, then if your consecutive angles are supplementary, it must be a parallelogram. So the answer to quick check number 1 is yes. Theorem 6.2 states that opposite angles of a parallelogram are congruent. We're not going to go over the proof of this, but hopefully you will agree that that is true. Example number 2 asks us to find QR and PS. Well, since we know opposite sides of a parallelogram are congruent, we are simply going to set 3x minus 15 equal to 2x plus 3. To solve this, we will subtract 2x from both sides. We'll get x minus 15 equals 3. Then we will add 15 to both sides and get x to equal 18. Then you're going to plug 18 back in for x for both of those. So that would be 36, 54 minus 15. I think this is going to be 39 for PS, and let's see, 54 minus 15. Yep, 39 as well for QR. Quick check number 2 asks us to find the value of y and then the measure of all 4 angles. Well, since we know opposite angles of a parallelogram are congruent, we are simply going to set 3y plus 37 equal to 6y plus 4. What are you going to do next? Hopefully you would say you're going to subtract 3y from both sides. I'm trying to get y by itself. So you get 37 equals 3y plus 4. And we will subtract 4 from both sides. 33 equals 3y. So y equals 11 once you divide both sides by 3. So if y equals 11, that's 33. A measure of angle G, when you plug in 11 back in for y, hopefully you'll get G to be 70. And the same for E. 66 plus 4, 70, excuse me. That should have been 70 here. And if consecutive angles are supplementary, then the measure of angle F must be 110, and the measure of angle H has to be 110, because consecutive angles of a parallelogram are supplementary. Theorem 6.3 states the diagonals of a parallelogram bisect each other. So we're going to try to look at the proof of this, but hopefully you will understand that we're trying to get, if the diagonals bisect each other, if we can get AE equal to CE and BE equal to DE, then we can say the diagonals are bisecting each other by definition of bisector, by definition of segment bisector. So, what are we going to say first? Please pause the video while you try to figure out step 2. Before we do step 2, let's see if we can get a plan. If we can get these two blue triangles, triangle ABE and triangle CDE, congruent, then we can say the red parts, AE is congruent to CE and BE congruent to DE by CPCTC. So our goal is to try to get these two blue triangles congruent. Well, if this is given to be a parallelogram, which it is, then we can say angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, because if parallel lines, then alternate interior angles are congruent. Next, we will say that AB is congruent to CD, because opposite sides of a parallelogram are congruent. Then our triangles will be congruent by angle side angle. All right, let us begin. All right, step 2 needs to be that AB is parallel to CD by definition of a parallelogram. If you have a parallelogram, both pair of opposite sides are parallel. Step 3 would then be 1 is congruent to 4, and angle 2 is congruent to angle 3, because if parallel lines, then alternate interior angles are congruent. Step 4 would then be segment AB is congruent to segment DC, because opposite sides of a parallelogram are congruent. Step 5, the two triangles are congruent by angle side angle. And since the triangles are congruent, we can say AE is congruent to CE, and BE is congruent to DE because of CPCTC. And then step 7, which I do not have room to write down, which would be what you're trying to prove. Segment AC and segment BD bisect each other at E because of definition of segment bisector. Example 3 is asking us to figure out, now that we know that the diagonals of a parallelogram bisect each other, to try to figure out x and y and then get the segments, each part of the diagonals. Well, how are we going to do it? Well, you know two things. You know x plus 1 equals y, and you know that 3x minus 7 equals 2x. How are we going to solve these two equations? You are going to use, from algebra class, substitution. Since y equals x plus 1, we're going to take x plus 1 and plug it right in for y into the first equation. So you're going to have 3 times the quantity of x plus 1 minus 7 equals 2x. You see where we plugged in x plus 1 in for y into the first equation? So then you're going to distribute your 3x plus 3 minus 7 equals 2x. So you'll have 3x minus 4 equals 2x. Then you will subtract 2x from both sides. You could subtract 3x from both sides at this point, but I like to keep my variables positive. So you get x minus 4 equals 0. Then add 4 to both sides, and so you're going to get x equals 4. Once we get x to equal 4, then we can plug it back in, and we can find y must equal 5. So x equals 4, y equals 5. Then we can plug it back in AE, if y equals 5, that's 15 minus 7. So AE has to equal 8. And EC better equal 8 as well. And then BE is going to equal BE 4 plus 1, which is 5, and DE is just plain old Y, which is also 5. So you got all 6 answers that they were asking for. Quick check number 3 is asking us to find the values of A and B. Please pause the video while you try to figure out both A and B. Okay, since we know the diagonals of a parallelogram bisect each other, we know B plus 10 is going to equal 2A minus 8. And we also know that A is going to equal B plus 2. Alright, well, we are going to again substitute B plus 2 in for A into the first equation. So we're going to get B plus 10 equals 2 times the quantity of B plus 2 minus 8. First we will distribute the 2. 2B plus 4 minus 8. Then you're going to get B plus 10 equals 2B minus 4. Subtract the B from both sides, 1B. So you get 10 equals B minus 4. Add 4 to both sides and you get B equals 14. And if B equals 14, then A must equal 16. And plug it back in. This side of the equation is then going to be 24. We better get the same thing on the other side. 2 times 16 is 32, minus 8 is 24 as well. Page 315 we will go over in class with both the front and the back group. So this concludes lesson 6-2.